Good afternoon, boys and girls, the class of 2015. My name is Mrs. Malahlela. I'm from Nyorala Tuto. I am teaching physical sciences. So today we are going to do vertical projectile motion revision and also Newton's second law of motion, but we are going to start with vertical projectile motion. The first thing that I want you to do, when you look at your screen, you'll find that I have a copy of an exam guideline. Each and every learner must have a copy of exam guideline because it is very much important to use this exam guideline every time when you practice, when you prepare yourself, whether it's for the test, whether it's for the homework or whatever that you will be preparing yourself for. And then you must use this exam guideline as a checklist. Let's look at the exam guideline. For vertical projectile motion, we have the first point. It says, explain what is meant by projectile. That is an object upon which the only force acting is the force of gravity. That is the definition for projectile. And what I like about exam guideline is that they will give you the definitions. And if you learn these definitions straight from the exam guideline, you won't forfeit any marks during the exams. Then the second point is you must use equations of motion to determine the position, velocity and displacement of a projectile at any given time. That is checkpoint number 2. And then number 3, you must be able to sketch position versus time, velocity versus time, and acceleration versus time graphs for a free falling object, an object thrown vertically downwards, an object thrown vertically upwards, bouncing objects. And then number 4, we have for a given x versus t, or all the graphs determine the position, displacement, velocity or acceleration at any time. Again, you must also be able to describe the motion of the object for bouncing, thrown vertically upwards and vertically downward. So when you prepare yourself with using this exam guideline, you will be clear, or you will be able to see which part did you not cover or which part did you cover, and also which part do I not understand better. Now let's move on to our topic of the day. When we talk of a vertical projectile motion, we are talking of the objects that are being projected. The object that is being projected upward or downward. So the projection will be there. But what is important is when this object is moving, how is this object moving? You must be able to determine the motion. What is the motion of the object? But while you determine the motion of object, you must also be very careful that when the object is moving, each and every object, whether it is projected upward or downward, we will have the initial velocity. Now, the other thing that is very much important, I know that your teacher told you that this object will be in a free fall state, but they will only be in a free fall state when there is no other force acting on this object except only the force of gravity. So the force of gravity, it is the only force that will be acting on this object, and this force of gravity will make acceleration to be constant. So the acceleration will only be constant if the object is in a free fall state and only the force of gravity is doing the work. When we look at the control test that you wrote, there was a point whereby you were given the magnitude of acceleration. Why were you given acceleration as 4.1? It is because there was an engine that was doing the work in the rocket. Then the engine made the rocket to be projected upward. Until the engine failed, that's when the rocket started to be on a free fall state. Now let's look at different types of motions that we have. Number 1, the ball can be projected from the top of the hill downward. Then projection number 2, the object can be projected from the ground and then reach the maximum height and move again down to the ground. That is the second projection, which means this one, for the first one, the object was projected vertically downward, but the second one, it was projected vertically upward, and it returned and came back, so it moved in two opposite directions. And then the third motion, the third projection can be from top of something, maybe the top of the building. The object is being projected from the top of the building, and it reaches its maximum height and pass the building and reach the ground. Then this is the third motion. And also when you look at this projection, it moves upward and also comes downward. The fourth motion will be whereby the ball can be projected from the top of the building or the object, and then when it reaches the ground, this ball bounces. So when it bounces, there is still a projection that is going on. So you must be able to calculate whatever that will be required to calculate depending on the kind of the motion that you are given. And also according to the exam guideline, you must also be able to describe the motion of the object. And also when you do your calculation, you must be able, after doing everything, you calculated whatever that you've been asked, you must be able to use the equations of motion and also the magnitudes that you calculated to be able to draw the graphs, the velocity time graph, and also the position time graphs, acceleration time graph, and also displacement time graph. Now let's move on. Then I talked about a free fall, when the object is in a free fall state. This means that our acceleration, or g, will be constant, and the magnitude of acceleration will be 9.8 meters per second squared. The magnitude of g do not change. It remains constant, provided that the motion is in a free fall state. And also, during the exam or the test, you are given the table of formulae, whereby you will be given the equations of motion. In grade 10, you were taught about the equations of motion. So the equations of motion are the one that we use for calculating the displacement, the time, the velocity, and also the delta x. Now, let's write down the equations of motion. The first one will be VF. VF stands for the final velocity is equals to VI plus A delta t, whereby we know that A, it is acceleration and it is constant, and delta t stands for time. VI is initial velocity, VF it is final velocity. And also the second one be VF squared is equals to VI squared plus 2A delta y. But when you look at the table of formulae, delta y is given as delta x. So it doesn't matter which one do you use, but what is important is delta y is for the displacement. And then the third equation will be delta y is equals to VI delta t plus half A delta t squared. Then the fourth one, which is the last one, will be delta y is equals to, in brackets, VI plus VF over 2 times delta t. So when you look at all these equations, you'll find that initial velocity is present. Out of all these 4 physical quantities that we talk, 5 physical quantities that we talk about, each and every equation have the initial velocity, which means each and every object that is in motion, whether it is projected upward or downward, the initial velocity must be there. Then you must be able to know the magnitude of the initial velocity. Then when you look at equation number 1, we have 5 physical quantities for vertical projectile motion. Equation number 1 do not have the delta y. So which means when you are required to calculate delta y, there is no way you can use equation number 1 because it does not have delta y. And then when we look at equation number 2, do not have delta t. So if the question says calculate the time taken, you cannot use equation number 2 because it does not have time. So it is very much important to know your physical quantities, to know your symbols, so that you are able to choose the correct equation. Then equation number 3, do not have VF. So when you are required to calculate final velocity, you cannot use VF. We cannot use this equation to calculate VF because it does not have that variable in the equation. Then in equation number 4, we do not have acceleration in this equation. So all these things that are not in the equations, please do not use them. So what is important, always when you are required to calculate something, think with your pencil. Write down what you think is important. Then after writing down your data, you will be able to choose the correct equation. Now let's move on to the first question.